Hello, my name is Anders Carlson, and the title of my study is The Influence of Muscle Fatigue on EMG Amplitude for Submaximal Isometric Contraction of Wrist Flexors and Extensors. A little bit of background for the study is that neuromuscular fatigue involves various causes and mechanisms, including central fatigue, fatigue of the nervous system, and muscle fatigue. Methods the body uses to compensate for fatigue to maintain force-generating capacity includes adaptations to firing rate and increased motor recruitment. EMG has been established as an effective method in monitoring local muscle fatigue. Surface EMG is generally associated with an increase in amplitude during fatigue, although some studies have shown conflicting results. The purpose of the study was to evaluate how fatigue at submaximal effort influences muscle force and SEMG amplitude. Our hypothesis was that SEMG amplitude will increase to maintain constant force in response to fatigue. The study consisted of 8 subjects from the Regis DPT class of 2019 who were recruited as volunteers. The mean age for the subjects was 24.3 years old, and 75% of the subjects were male and 25% were female. The methods included placing EMG electrodes over the belly of the wrist flexor and extensor muscles of the subject. Maximal voluntary contraction was measured using a hand grip dynamometer. Subjects then completed the fatigue test, in which they maintained 25% of their maximal voluntary contraction force in the hand grip dynamometer as long as possible up to 300 seconds, recording force and EMG amplitude every 15 seconds. The data is shown in Figure 1 and 2. The trend line generated for the EMG amplitude data showed a minor decrease with time. The trend line generated for the force data indicated that force remained relatively constant over the course of the experiment. However, there was no significance in these results due to the high variability of the data shown with the error bars in each figure. In conclusion, the data was unable to support our hypothesis of an increase in EMG amplitude with fatigue. While the trend line generated for EMG amplitude showed a slight decrease with fatigue, this result was insignificant due to the variability in the data. Error associated with preparation and differences between subjects may have attributed to this variability. Most literature indicates that EMG amplitude should increase with fatigue due to higher motor recruitment needed to maintain force production. The clinical relevance of our results is that EMG can be a useful tool to assess local muscle fatigue during an activity. However, it is vital to standardize procedures to reduce variability in measurement. In addition, measuring a decline in the frequency spectrum may be a more reliable method to assess fatigue from a clinical standpoint. Thank you for listening.